All right, so today's talk is going to be from a good friend from the University of Oregon and NSRC, David Teach, and he's going to be doing, I think, the first in our set of talks about cool tools. We're going to hear a little bit about route views today, so I will turn it over to David, so take it away.
Thanks, Jason. Appreciate you having me on to talk about route views. So I'm David Teach. I'm the Senior Network Design and Development Engineer at the University of Oregon, and also one of the chief maintainers of route views today. And I just kind of wanted to give you guys a quick talk about what route views is, how we're evolving that platform, and how it's applicable to the folks within the CI Engage group here. So let's get started. So route views is a collaborative router looking glass service that we have that allows you to view each views among network operators and researchers. So it was founded at the University of Oregon in the Advanced Networking Technology Center in 1995. We have data archives that begin in '97, and it's about 28 terabytes of data today that's compressed. And as I mentioned, it's currently led by myself and a group of engineers at the University of Oregon with help from the NSRC and engineers from ESNet. NSRC, if you're not familiar with them, they support the growth of global internet infrastructure by providing engineering assistance and collaborative technical workshops, training, and other resources to university and research education groups worldwide. They've been around for a long time, and they do a lot of good work within our community. And obviously the University of Oregon, that's where I'm from. It's also where NSRC is housed, and we've been around for a while as well. So here's kind of a quick look at the route views collector footprint. I'm not going to iterate through all of these, but as you can see, we have a lot of collectors. They're fairly geographically diverse, so we actually have a pretty good coverage of the global routing infrastructure from multiple vantage points across the globe. And we'll get into some more of these details later on in the presentation. So just some quick peering stats. We see, roughly about 200 million prefixes at any given point during the day. We have about 600 peering sessions going at any given point, and we see about 263 unique ASs throughout the day. And if you're looking for more information on those peering stats, you can go to the link there. At the bottom, we try and keep that page as up to date as we can. So that's also always a good resource there if you're looking for peering information from route views. So the general deployment for a collector is pretty straightforward. In cases where we're using hardware, it's a fairly modest, one-use server that we would deploy at a given exchange. So, 18 to 16 cores, 64 gigs of RAM, a terabyte of SSD, and 1 to 10 gig interface, depending on what the exchange fabric looks like. We do also have a single Cisco ASR that we use as our single kind of vendor-supported router. In addition to what we use on the open source side. And in terms of open source software, this is just run-of-the-mill CentOS Linux. Some of our older collectors are running Quagga as their BGP daemon, if you're familiar with that. Most everything that we've deployed in the last 3 to 4 years is running FRR, which is a fork of Quagga. But both of those products have been very stable for us, and we've been happy with both of those. There's essentially 2 ways that we operate our collectors. There's the multi-hop model, where essentially it's BGP multi-hop. If you can reach the collector, you can peer with us. And then we also have the internet exchange model where we actually have a VM or a server connected on an exchange fabric, and we peer directly with the other peers there. Some of the issues that we see in terms of pros and cons with the multi-hop model is we can basically support anyone that can stand up a BGP peering session with us. The problem is that what we run into is that if there's any anomalies or any issues within BGP in the path between our peering session with you, we lose that information, or we have the potential to lose it if that peering session is taken down. Versus the exchange model, where as long as we're on the peering fabric and we're able to reach you, the likelihood of us losing that data drops significantly. So those are kind of what we try to push people towards when we're looking at standing up new peers for route views. And we also get a little bit of diversity out of that internet exchange model. So route views data is based on the MRT RFC, which is the multi-threaded router toolkit. Essentially, it's a binary dump of routing data, excuse me. So we take BGP ribs and BGP updates from our collectors, and we dump those every 2 hours and 15 minutes respectively. And we'll have some links later on here about how you can get to that data. So, oh, there you go, yeah. So data access, we bzip the MRT files and we rsync them back to our server archive. And you can access those at any given time via HTTP, FTP, or rsync. They're all available all the way back to 97, so the data is there for you to do any sort of historical analysis that you might need. Here's just a quick list of MRT tools in terms of parsing and analysis that we found to be useful. I'm not going to try and read through all of these, but if you're interested, take a look. A lot of these are really good tools. I will point out that Kata's BGP stream tool is great in terms of taking an MRT file and handing you parsed data that you can quickly use in your analysis. So let's talk a little bit about how you can actually access these collectors. So all of our collectors use Telnet. There's no username or password necessary. This is an open service, so there's no real need to do any sort of user access there. And then it's essentially, FRR is very similar to what you might get from iOS. So any of those show IP BGP commands you might expect are typically there, and you essentially have free reign to do whatever you need to in terms of looking at the global routing infrastructure through any one of our collectors. A couple of things that we typically run into is people ask us, well, why aren't we using SSH? Well, like I said, we don't really have anything to hide. There's no passwords there. There's no data that's sensitive. So Telnet works for us in that case. And we don't have to worry about older keys or anything like that. We also use SSH to manage the actual host, so we kind of are able to avoid that conflict by using Telnet. The other one that we run into is people say, well, I can't do a show IP route, or the next hop in this route is incorrect. You got to remember that this is a BGP collector, so there's no real data plane here. We're not actually forwarding traffic, so it's just control plane. So that's really where your ability to look into the routing table stops. So a couple of use cases, and this I think applies to this group well, is we all know that BGP is the backbone of the global routing infrastructure. it's essential for us to be able to look into that routing infrastructure and ensure that it's stable, and it needs to be constantly monitored. So that's one of the things that Route Views provides. We give you that command line looking glass access. We give you the ability to look at convergence and path stability or prefix visibility, all of those things. And because we have so many different advantage points across the globe, we have that global view set of the interesting bits within the routing infrastructure that you're looking for. Another thing that we see people use Route Views a lot for is just troubleshooting reachability in terms of what does my AS path look like between two endpoints. Route Views can help you take a look into some of those different anomalies. So the other piece that we see a great use case for with Route Views is on the research side. As you guys know, route leaks, BGP hijacks, all of those things are happening more and more frequently today. And that's something that I feel like we're able to provide the community another advantage point into some of those anomalies. In addition to that, we have a lot of folks that want to study those anomalies. So by handing researchers or making our data set public to anyone, we give them the ability to look into network topologies, to look at those route leaks and hijacks via different tools like Artemis and Cyclops. We also allow research to take place in terms of network optimization, growth or aggregation, and address province. So there's a lot of different research opportunities that you can use Route Views data for. And there's been roughly 500 research publications that have used Route Views data, which is something we're really happy to see. And if you're interested in some of those papers that have been published using Route Views data, we have a link there where you can go take a look at those.
Hey, David, I'm going to stop you quick because we have our first question that came in.
Sure.
Let me read it out. Has Route Views looked at enabling RPKI as an experiment or data point to see who is using RPKI and hopefully watching its usage climb over time?
Yes, so I'll get to that in a little bit. But yes, we are enabling RPKI, and that's a great question. So let's kind of look at what the first generation characteristics of Route Views as a platform kind of looks like. So today, that's basically file-based storage in the MRT data format. It's asynchronous, so you're having to we dump ribs every 2 hours, and we dump updates every 15 minutes. So you're kind of beholden to those time periods in terms of when you want to get that data. It's manual retrieval and sequencing. So if you want to compare ribs from two different collectors, you have to go pull that data down. You have to parse it and essentially merge that data together and sequence it in a way that makes sense to you. There's no post-processing, so it's just the raw file. We haven't done anything about removing null routes or any of that information. It's all raw data there. And it's a centralized model in the sense that there's one or two servers that you can get this data from. You can't necessarily go directly to the collectors and get the MRT data. And that's kind of made it a little tough in terms of facilitating easy access to the Route Views data set. And we've kind of looked at that and seen how we can improve it. And essentially what we've done is we've taken that to the next step, and we've applied some newer technologies and concepts to the Route Views platform to try to alleviate some of these barriers. So the second generation characteristics of how we do data distribution within Route Views, it looks something like this. It's a message-based data distribution model. So we have per message timestamps with the metadata about the message, where it was received, what collector, was it V4, V6, you know, all of that different metadata information is available in every packet. It's automated consolidating and sequencing, so you don't have to worry about you know, taking two files from two different collectors and merging those together. That's done for you. Database storage and access. So we're working on having a short period of time in which we can actually store that real-time data and provide access to that in a meaningful way, and in ways that you can use a database in terms of joins and lookups, and not making that sequencing and consolidation process such a barrier. RESTful interfaces, you know, every good service out there today has a RESTful API that you can use to make queries against. That's something that we're working hard to address. Real-time streaming telemetry. This is really the backbone of this second generation. You know, 15 minutes is a really long time in terms of waiting for BGP data or waiting for updates or waiting to see what has happened. So with this new this new wave of route views data distribution, we're able to deliver BGP updates in real time as they're received from the collector back to an endpoint that we manage at route views. And I think that's a really useful thing both for the operations community and also as a new interface for researchers to start looking at that data. Middle layer abstraction. So previously you kind of had to have an understanding of where our collectors were at and what file, folder, directory structure they got dumped into on our side, if you really wanted to piece things together from a geographically diverse set of collectors. We're able to do away with that entirely in this next generation of data delivery. And I'll touch on that a little bit here in a second, but we can really essentially only focus on what the client access really needs in terms of how they want to retrieve that data. And RPKI validation. As someone asked, we're actually turning on RPKI on all of our collectors here as we roll out new versions of that software. So let's talk a little bit about what that means. We are not actually validating or dropping prefixes that are coming in that are invalid. Essentially what we're doing is we've stood up a validator for route views, and our collectors pull down that data set from the validators, and we allow you to look at what those valid routes would look like or invalid routes would look like from any given collector. So that's something that we're hopefully going to be rolling out over the next year or so. And there's an easy way that you can go look at which collectors have RPKI validation turned on, and we'll touch on that here towards the end of the presentation. Hopefully that answered your question. So a couple of the other things that we've tried to focus on as we're evolving route views as a platform, we really want to find a better way to communicate with our users in terms of, you know, when we're doing maintenance or when we've seen outages or if we've stood up a new collector. So to help facilitate that, we've worked with the folks at NSRC, and we've essentially just stood up a user list for route views. So if you're a user of route views, or you've peered with us, or you're interested in what's going on with the project, please join the email list. And that's kind of the best way right now to stay informed about what's going on with the project. So the other piece of this is, you know, route views has operated for a long time based on the needs of the research community and based off of what we've received from peers of ours, and it's been very, I would say, request driven. In addition to that, we've tried to determine ourselves where do we need to go with route views in terms of where do we need new collectors, what are the new services that we can provide on route views. And it's kind of been a little bit of, design in a bottle. And essentially, we need to make sure that we continue to meet the needs of both the research and operations community. So we're working on standing up a steering committee to help facilitate that. And that'll be comprised of both research and industry members to essentially help us make sure that route views is continuing to meet the needs of the community. So let's talk a little bit about, and this jumps back into kind of that second generation of what the route views platform looks like. So to facilitate that, all the things that I talked about there in the second generation, we're leveraging BGP monitoring protocol as the kind of backbone of that delivery system. BMP is a RFC standard. You can go take a look at the RFC there. It's supported by all of the major networking vendors, and it's also supported in FRR, which is the open source routing stack of choice for route views today. We actually worked with the FRR devs to have that implemented within FRR in the last year or so. So we're really excited to be able to start rolling that out to our collectors. And what's great about BMP is we actually get a lot of other useful data within those payloads in addition to what we get from MRT. So we start seeing start and stop for peers, start and stop for collectors, peer up, peer down information. We get host names, we get router versions, so there's a lot of good information that we are able to glean from that BMP payload. So yeah, of course I got a little ahead of myself. BMP, as I stated, it's an RFC, so it's an IETF standard. We use OpenBMPD, which is our BMP collection server. It's open source. It's a part of the Linux Foundation. And essentially it consolidates peers and collectors for us. And it splits those collectors, peers, and updates into separate streams. And we'll touch a little bit more on that in a second. And then it also uses Apache Kafka as the message bus between the OpenBMPD servers who are doing the BMP collection and the consumers who are looking to subscribe or ingest that BMP data. And what's great about Kafka is, it's a pub sub model that has been tested by the industry and seems at this point really to be the kind of message bus of choice for a lot of people. It's proven to scale, that people have been very successful with scaling Kafka, and it has a mature client API. Essentially, there's clients in 16 different programming languages. So if you have a programming language of choice, there's probably a Kafka client out there that you can use. And it can be easily extended to meet future needs, whether that be via stream processors or any of the other things that Kafka provides. So there's a lot of room for growth there in terms of what we can do with Kafka as a message bus. So here's the essentially the OpenBMP architecture that we use with route views, and this is taken from OpenBMP's GitHub page. But as you can see down at the bottom there, we have our eBGP peers. That would be what we are receiving at a given exchange or from one of our multi-hop collectors from those peers. Those go to a BMP-enabled collector on our side. And then that BMP or that BGP data is encapsulated in BMP and sent to our OpenBMP service. They push that as a producer into Kafka, and then we make that data available via different topics to the consumers, which is essentially anyone who can write a consumer for Kafka or can use any of the tools that we'll mention later. So once you consume that data, you can use it for whatever your business need or research need is at that point. And the other great thing about Kafka is we can actually take that data and forward it out to another Kafka instance that someone could use and their data pipelining as well. So it's a very useful and versatile tool in terms of how we can collect and distribute this data. So let's talk, I'm going to give just a quick summary of kind of what a Kafka topic is and how it relates to the route views data. So a Kafka topic is essentially a category or feed name to which messages are stored and published. In terms of how that relates to our route views deployment of Kafka, we have essentially three types of topics. We have the collector topic, which is essentially data about what's going on with the different OpenBMPD collectors. We have router information, which is what we're seeing from our BGP peers or any other device that's sending us BMP data. That includes, BGP state up, down, or excuse me, BMP state in terms of, is the session up, is it down, what type of router it is, what version it is, etc. And then we have the actual BMP data. And what's nice about what we can do with OpenBMPD is we can actually group this data into elements of collector groups, which in our case might be, we might have a collector group for our multi-hop servers. And we might have a collector group for the AM6 exchange that we're at. And then, excuse me, that was the collector group is our BMP servers. The router group is what we might group our multi-hop routers or an AM6 router to. And then we also have the peer ASN. So all of that information is split out into separate topics. And essentially what you can do with a consumer, Kafka consumers support this idea of a subscribe pattern. And that subscribe pattern essentially is a regex. So given the information that we know, we can do things like build a regex for subscribing to all the updates from all of the ESNet peers that RapViews has, which I think is a really cool thing when you think about how that compares to our kind of first generation data distribution. To do that, you would have had to walk through all of our different collector files and figure out where ESNet is peered with them and then merge that data. All you need now is a regex. In addition to that, if you want to look at all of the data coming from our multi-hop peers, you can build a regex for that. So it's very powerful in terms of you can be as general or as granular as you want in terms of the data that you want to subscribe to. In particular, I think there's a great use case for a lot of folks in this room, whether you be a regional or a campus or some other entity in terms of, I want to see what's happening with my AS or my prefixes. You can do that very easily with the consumer subscribe pattern. So a couple of tools in terms of parsing or ingesting BMP data. CADA, if you're not familiar with those folks, it's the Center for Applied Internet Data Analysis out of UCSD. They've written some awesome tools that plug directly into what we're doing here. They also actively develop on OpenBMPD. So they kind of have that 1-2 punch of making sure that their tools are going to work great with what we're doing here. So if you haven't checked that out, go ahead and check out BGP Stream because that's a great tool, and we're working very closely to make sure, working closely with them to make sure that it continues to be a useful thing for the community. And there's a number of different languages, as I mentioned before, that you can get a Kafka client in. So if you're interested in writing your own parser, you can check out Apache's link here and see what's available. So there's a couple of different things that I think we can enable as we look at this second generation of route views distribution. So there's kind of some new and novel approaches to BGP anomaly and dynamics that we can really leverage here now that we're able to deliver BMP data in real time. So one thing that I think would be really great is for someone to use that real-time streaming telemetry with supervised machine learning, and to see if we can do a better job of detecting route leaking, hijacking, or detecting infrastructure and peering outages, internet censorship, routing policy complexity. There's a lot of different opportunities that I could see being able to take essentially the route views data set, whether it be that MRT data to train an ML against, and then actually let it loose on the live BMP streams to see, how effective or how well we can monitor those events. And that's really that's the end of the presentation. I have a couple more things to show you, but I figure, it's a great time to pause for questions. And before we do that, I just want to say thank you to everyone involved, whether you are a peer of route views or you support route views by hosting a collector or any other way that you might support route views. Thank you very much, because we are 100%, based on the goodwill and merit of this community in terms of keeping this project going. And if it wasn't for you guys, I don't know if we would still be here. So I really appreciate each and every person that continues to support route views. So if we have any additional questions, we could probably pause for that. If not, I can jump into the second piece of this.
Sure. So we had two questions come in, and I have a couple as well, but I'll read off the ones from the chat room first. So Michael Lambert wants to know, have you looked at BIRD or OpenBGPD as collectors?
We have the issue, at least we looked at BIRD and OpenBMPD or OpenBGP when we were initially looking at how can we leverage real-time streaming, or how can we bring real-time streaming to the route views platform. And there weren't any collectors that were, or BGP daemons that were doing that at the time. And being that FRR was a fork of Quagga, that really made a lot of sense for us at the time. I know a lot of folks are very happy with BIRD as a collector, and in terms of the data that you can get out of it. And it probably makes sense for us to continue to evaluate those to see if it makes sense to use those within the route views infrastructure. But that's essentially kind of where we drew the line is, FRR makes sense. We approached the developers of that project who are very, community driven. They're very easily approachable. They're very easy to work with. And we said, hey, we'd love it if you guys would help us get BMP into the FRR stack. And they were amenable to that, and we worked on that for about 6 or 8 months, if not more, to get that into the FRR stack. And that's kind of been where we really said, okay, FRR is the routing suite that we're going to be using for the foreseeable future. Hopefully that answered your question.
Okay. Yep, Michael said that did. Next one from Jim Warner. He's curious about what your funding stream looks like right now. How are you funded?
That's a great question. So we have a small bit of central funding from the U of O. Other than that, we are funded either through grants through the National Science Foundation, or we're funded essentially by gifts from private industry. And if you look back at the history of route views in terms of funding, I would say the vast majority of it has been and grant funded through either us being attached to a National Science Foundation grant, or us applying for National Science Foundation grants as well. There hasn't been a ton of funding, and there still isn't today a ton of funding from private industry, which is something that I feel like is backwards, right? Private industry shouldn't be the folks here that are using the service for free, while the National Science Foundation and universities or entities in the public research space continue to fund route views for their purposes. And I think that's something that we really need to try harder at addressing, and talk to some of those big users of route views on the private industry side to see if we can get them to contribute, so folks within the research community aren't stuck footing the bill for this project. Did that answer your question?
I think so, and then Hans from NSRC also helpfully shared a link, so
oh, great.
we can
Thanks, Hans.
we can see a little bit about that.
Okay.
Next question from Matt Zakauskas. He's asking about statistics. Early on, you showed the statistics of you guys are seeing about 200,000 routes. First of all, he wants to know, is that IPv4 only? And second, he notes that the global table is closer to 800,000. Any ideas why you're only seeing about a quarter of those?
So I think the stat was we see roughly 200 million prefixes. So we see about 200 million prefixes that are advertised to us. Obviously, there's a lot of duplication in there, right? I mean, everyone that advertises a full table to us, those are essentially the same prefixes. We just see them, 100 different times. And those stats do include V4 and V6. So if you go to that peering status page, we have a breakdown essentially by collector and by AS and by address family in terms of what routes we're receiving from that peer. So hopefully that kind of clears that up. I hope I answered that question.
Okay. Matt says, yep. And let's see, we got 2 more here.
Sure.
Is it possible to collect metrics? I'm sorry, first of all, Rodrigo is asking, is it possible to collect metrics about RIB and FIB tables separately?
Maybe. So you have to remember that there's no FIB on the collectors, right? It is just control plane. It's just BGP data. So essentially what I see a lot of folks doing in terms of using the route views collector, so the Telnet interface of the collectors is they do show IP BGP best path. And essentially that's kind of the pseudo fib in terms of what route would be selected for this prefix, but we don't actually have a fib on most of our collectors. The one ASR that we do operate does have a fib, but what you would find is that every route points, the same direction out to the essentially the default gateway of where that next hop is. So that fib there isn't super useful like it would be at a given exchange that one of our other collectors might be at. Does that make sense?
Yep, that worked for Rodrigo.
Okay, and just I guess to jump into that a little bit, we have, or back into that, we have looked at how we could collect some of that additional metadata from the BGP daemon in terms of, using something like Prometheus and Telegraph to essentially grab some additional metrics there. That's yet another project that we would put in the bucket of, boy, it would be awesome if we had the time to jump on this one. So it's been discussed, but I don't think we have a clear solution for it today.
Okay. Two-part question from Henry.
Okay.
I'll do these in order. In the
Cool.
current infrastructure, is Telnet Automation allowed?
Yes. So yes. Here's one thing that as you start to look at automating against collectors, you need to be aware of. We do have to, because it is a public resource and because they're open to the world, we do have to kind of wrap some of those resources. We need to put some safeguards in place. So essentially, if you want to automate against route views, you will find that if you start logging in rapid succession, you will hit IP tables timeouts. Essentially, so if you're going to automate against route views, you're much better off to just use a single session, connect whatever commands you want to run them, get that data, and get out. So that would be the only caveat I would say to Telnet Automation. Otherwise, there's nothing that is really off limits in terms of what you can try and automate against route views. I will say, again, public resource, so please be respectful of that resource. We have a lot of folks that tend to use and abuse those collectors, and I'd love to be able to throw a collector at an exchange that can just be hammered away on, but unfortunately we can't. So we need to be cognizant of those resources and how to use them.
Okay. And the second part of Henry's question, which I'll admit I actually had this question too, is there any effort to standardize the live data format between route views and RIPE NCC RIS that uses WebSockets for live data streams?
Yeah, so we've looked at that. So yeah, RIS is using WebSockets. We actually wrote essentially a WebSocket parser or add-on to the Kafka client. And essentially, once we do that, there's no reason that we couldn't massage the data that we're getting from BMP into the WebSocket format. So someone could, for example, subscribe to route views and RIS and get that, essentially that full view from both services. What we found from the folks, the heavy users of route views and the folks that are really leveraging that data, is that the WebSocket, excuse me, WebSockets as it relates to some of the lower level programming languages like C or C++ can be a little difficult to deal with. So they really urged us to use, excuse me, they were really urging us to expose Kafka directly to the consumer, because that makes it very easy for anyone and everyone that has a platform that they want to bring to route views to ingest that data. But it's not at all out of the question. Like I mentioned previously, Kafka is very extensible, and there's some stream processors that we might be able to leverage to make this a very easy thing to essentially build a like-for-like interface, just like RIPE RIS is done.
Okay. And I think this is the last one from Byron. Any thoughts about resurrecting the visualization tool minus the Java? I think it was called BGP Play.
BG Play.
BG Play, yes.
We, excuse me, needed some water. Visualization obviously is a huge part of data analysis, and it doesn't go without saying that BG Play was a useful tool. It wasn't ever a project that we managed or maintained, so we were kind of beholden to what those folks were doing. I don't know if I can tell you right now that we have a plan to resurrect that or plan on having another tool that's available to do that visualization. I think you're absolutely right in terms of That's a very useful thing that we need. But route views itself doesn't necessarily, I don't really see ourselves as the one that's doing the data analysis piece of that. I really think of us more as like, you know, routing information librarians. We essentially make sure that the data arrives and it's categorized correctly, and it's put in the right place for people to go do the research. My guess is that there's folks out there within CADA or some of the other research groups that would be better suited to do that. Hopefully that answers your question.
All right, I think that is the end of the questions. Yep, Byron said that that did. And Nick also shared the router views map. So
oh
that is in the.
He totally, thank you, Nick, but you stole my thunder a little bit. That was essentially the next piece of what I wanted to talk to you guys about.
Okay, we'll go for it then.
Cool. So a couple of months ago, we were having a conversation with the group at UCSD, CADA, and Casey Claffey, if you guys are familiar. I don't know if she's on the call or anyone else from CADA is on the call. But we were talking to her, and she essentially said, you know, it'd be really great if we had a map of route views data, essentially to kind of facilitate some of the visualization that we were just talking about in terms of, you know, where do we have collectors and how are they peered, what regions are they in, all of those things. So we took that information and we partnered with the infographics lab here at the University of Oregon, who's done a bunch of amazing work, more based on the geographics and not, you know, collectors and exchanges and all of that. But they helped us create this map. And when I say help, they did a lot of work, mostly on their part to create this map. And essentially, this is the visual representation of the route views footprint as it is today. So what's great about this is, you know, we can jump into different regions of the world or RIRs and see what's going on with the data and what our collectors are doing. It's all filterable. So if you want to look at, I mentioned previously, which collectors are doing BMP or RPKI, you can filter by those and start to figure out, okay, if I want to look at RPKI data, I should go connect to AM6 or Links or one of those. We can also filter by the collector type here. So there's a lot of things that you can easily go to this page and start to get a pretty quick understanding of where or what I can use the route views data set for. In addition to that, we've also worked on what are the interesting metrics that we should use or that people might be interested in. So the one that kind of came to mind was these are number of peers between V4 and V6 over time for collectors. And I believe you can sort this by a given collector. Yep. So there's a bunch of, and obviously, so route view 6 is a V6 peering only, so that's why you don't see any V4 peerings there. But you can, in addition to that, you can also change the range here to start to give you an understanding of what that data looks like over time. And this is really just metadata, right? I mean, we're not providing actual, the ability to look at prefixes in here, but the hope is that you can use this and say, okay, here was an interesting time period where, you know, we saw a spike in V6 peerings. What happened there? Well, if you want to, you know, highlight that area and then go jump into the MRT data set and actually look at that, this essentially helps facilitate that process. And one thing that we're working on bringing as functionality to this map is to actually be able to select that timestamp and then generate some BGP stream output that you could go run on your BGP stream instance and start looking directly into that data set from the timestamp that you just selected, which I think is really cool in terms of looking at where we were in terms of route views data, you know, in terms of asking those questions and coming up with an answer, we're able to short circuit that process in terms of, I have a question about data from this collector at this timestamp. Okay, plug this into BGP stream. Now I can go see what's going on. So I'm really excited about what we've done with this map, and I'm super thankful from the folks at the GIS department for working with us on this. And your feedback here is absolutely welcome. If you see things here that you think we can improve on or make better, you know, that's information that we want to see and hear from you about. I will note one other, there's a couple of great features about this, but, and please, you know, go to the URL here or that Nick posted and walk around and poke around and see what you see and let us know what you think. But the one thing that I wanted to highlight here, if you want to peer with route views and you're curious about where we're at or where you can peer with us, at this point, if you know that you're at a given exchange, so for example, eQuix, you can open up eQuix and this should pop out to a mail to link to help at route views with the collector information. And essentially you can plug in your AS and your IP and that will send us a peering request with all the information we need and we can start peering. So another way that we're essentially trying to short circuit how we're allowing people to get involved with the route views data set. So yeah, please, you know, poke around, send us a peering request. That would be great. And give us your feedback. And that's all that I had for today. If there's any questions about the map, I'm happy to field those as well.
Looks like just a couple of other comments in the chat room, mostly about the map. Thanks to Dale and Hans for sending along a couple more links for everybody to see. So we'll pause here for a minute and see if anybody else has any other questions. I guess I just had one more. What's the best way for people to try to participate with this? Email you directly, or is there a general list that people can just contact?
Help@routeviews.org is the best way if you have questions, if you want to send us a peering request, any of that stuff. You can also go to our website and just click on the contact information here at the top. And you can just fill out a simple field, a simple form here. We also have the subscribe link for the route views user list here, and just send us your question. This sends us an email to help@routeviews.com. And that's, you know, that's where we get all of our peering requests today, and that's the best way to get a hold of us. And that's an alias for a number of different people within route views. So you'll get a response from one of us.
Okay, well, hopefully every regional network that's represented on this today will send a peering request if they haven't already done so, and maybe somebody can even host another collector. Looking at you, Deaton.
I would love that. Please, please let us know. And we're, you know, I don't know if it got explicitly mentioned. Well, I know I didn't get explicitly mentioned in the top. The one thing that we're also looking at and that we've kind of received feedback on is that sometimes the one-off BGP peering with route views can be a little bit cumbersome for, you know, whether you're an ISP or regional or whatever. But if you have a BMP enabled router, you know, you can start sending those BMP sessions to route views and we can collect them there too. So if BGP is a little more cumbersome than what you would like, think about sending us a BMP session and we can get that stood up as well. And then the one other thing that I'll add is if you're thinking about hosting a collector, you know, we don't necessarily have to have, you know, a physical machine at that collector. A lot of what we've done in the last year or 18 months has been VMs from people that have virtualization resources at an exchange. So if you have a VM or a cluster at an exchange for whatever reason, and you're able to get us an interface on the exchange, you can absolutely host a route views collector And that really is the preferred method for us today, because it's so much easier to deal with something that's virtualized when it's halfway around the world than it is, one new box that someone's going to have to go lay hands on if there's an issue, with power or disk or whatever. So VMs are great.
All right, perfect. Well, no other questions. So thanks again for doing this, and we'll make sure that we get the video posted. And if you are still listening, next week's talk is going to be about the data movement exhibition, and it's probably going to be me giving the talk. So hope to see everybody there. Have a good weekend and stay healthy.
Thank you.